Okay, so problem 2, and the only difference is that we still need to find the average value, but we just need to locate the x value that yields that average value. So let's see. So for 2, once again, let's find the average value. So we need the antiderivative of this x minus 3 squared. We're looking at this between 2 and 5, and I need to divide the whole thing by 5 minus 2, which is 3. So I'm going to put that out in front. I could multiply this out, but I don't feel like it, so I'm going to use u substitution. That's dx. So u is x minus 3, and then du is just dx. So this is going to become 1/3 antiderivative of u squared du, and our limits of integration change. 2 minus 3 is -1. 5 minus 3 is 2. So this is going to give us the 1/3 will carry along. Antiderivative of this is just 1/3 u cubed between -1 and 2. -1 and 2. So we're just going to have 1/9 of 2 cubed is 8 minus -1 cubed is -1. So just 1/9 of 9, which is 1. Okay, so the question is, where on the graph of, we know what this looks like, right? We know it's a parabola. We know the vertex is at 3. It's going to be something like this. Here's 2, 3, 4, 5. Okay, so we're looking at this part of the graph. We found that the average y value is 1. Let's see, which is probably, in fact, which is right here. So which x value gives us 1? So where is our output equal to 1? I'm going to solve this by square rooting both sides, so that gives me plus or minus 1 is x minus 3. So x minus 3 is 1. So one place is 4, or the other place is where x minus 3, is -1. So x is equal to 2. And both of those are places on our interval that yield the average value. Okay, same situation. We're going to take the average value of this, so I'm going to have 1/2 the antiderivative of 2x, 1 plus x squared dx. Obviously, this is a u substitution situation. So here we have, let's let u be equal to 1 plus x squared, and then conveniently, du is 2x dx, which is exactly what we have. So here we have 1/2. We'll change those limits of integration in a second. This is going to give us 1 over u squared, so I'm just going to write that as u to the -2 du. Limits of integration then are going to be 1. Let's see if x is 2, that's going to give us a 5. So 1/2 antiderivative of u to the -2 is 1 over -1, u to the -1 between 1 and 5. So that's -1/2, and we're going to have 1/5 minus 1, which is 1/5 minus 5/5. So this is -1/2 times -4/5. So that's just going to give us 2/5. So again, where is this thing going to be equal to 2/5? So let's just solve that equation. Where is 2x over 1 plus x squared going to be equal to 2/5? I'm going to divide both sides by 2 just to get rid of that, less to worry about. And then cross multiply. So we have 1 plus x squared times 1 is equal to 5x. Well, I guess I'm going to have to multiply this out. 1 plus 2x squared plus x to the 4th is equal to 5x. Set it equal to, ooh, shoot, I don't know what to do with this. This is kind of terrible. X to the 4th plus 2x squared minus 5x plus 1 is equal to 0. Well, I think this is a situation where I'd pull out my calculator, which I'm not going to do right now because it's going to take too long on this computer. But the point is, you're practicing average value.